Breathing in moon dust can still give you what one astronaut called lunar hay fever. Moon dust may not be as harmful to humans as had been thought, with a new experiment showing that the typical air pollution on a busy street is more toxic than inhaling lunar dust. The results contribute to the safety case for returning humans to the moon, said Brian Oliver, who is a distinguished professor of life sciences at the University of Technology, Sydney, in a statement. Concerns about the toxicity of moon dust arose during the Apollo missions. Lunar dust is statically charged, allowing it to adhere to astronaut spacesuits. After the astronauts clambered back inside their lunar lander following a moonwalk, the dust became airborne in the cabin and was inhaled, leading to the astronauts suffering respiratory problems that faded after about 24 hours. Apollo 17 astronaut Harrison Schmitt described it as like having lunar hay fever with stinging eyes, sneezing, and a sore throat. Moreover, back on Earth, the Apollo flight surgeon reported similar problems after unpacking the used spacesuits. In their case, they reported that the symptoms grew worse after every mission, suggesting that repeated exposure to lunar dust exacerbates its toxicity. Nevertheless, the anecdotal evidence is not a quantitative measure of the potential harm that lunar dust can do to humans. So Michaela Smith, who is a PhD student at the University of Technology, Sydney's Respiratory Research Group, set about finding out. Smith performed experiments using 2 lunar simulants, replicas of real lunar dust, since samples of real lunar dust are limited, that are analogous to moon dust found in the moon's dark volcanic lowland plains and its more ancient highlands, respectively. The simulant particles are smaller than 2.5 microns, millionths of a meter, small enough to be inhaled and then trapped in the lower airways of the lungs. To represent lungs, Smith introduced the simulant dust to 2 different types of lung cell, namely bronchial and alveolar cells, representing the upper and lower regions of the lungs, respectively. Smith then conducted the same experiment, but with airborne particulate matter, sampled from a busy Sydney street, and compared the effects of lunar dust with that of air pollution. Smith found that while the irregular shape and roughness of the lunar dust still irritates the lungs, its effects are significantly less than that of air pollution. It's important to distinguish between a physical irritant and a highly toxic substance, said Smith. Our findings suggest that while lunar dust may cause some immediate irritation to the airways, it does not appear to pose a risk for chronic long-term diseases like silicosis, which is caused by materials like silica dust, as on a construction site, for example. This is good news for NASA, who are still taking the health challenges of moon dust seriously as they plan the Artemis 3 mission that will see humans return to the surface of the moon for the first time since 1972. For example, one strategy is to have the astronaut spacesuits affixed to the exterior of the lunar lander, and the astronauts enter and leave the suits through an airlock within the lander, without bringing the moon dust stuck to the suits inside the cabin. However, thanks to Smith's work, the problem of moon dust is perhaps no longer quite as serious as had been anticipated.